Tools for software reverse engineering. With the concept and the processes involved in software reverse engineering detailed out, we are now set to set up a practical lab. But before that, let's first identify some of the tools used in performing software reverse engineering. A sandbox tool is a formal software reverse engineering tool. A sandbox tool is an isolated testing environment that enables software developers to run and test a design software and as well as to open software files that may be infected with a malware without compromising the host computer or device. To simply put, a sandbox is a concealed environment created within an operating system but separated from the host operating system environment for the purpose of either testing or running a software or for the isolation of data from the host operating system of a device. Aside the purpose of testing and data isolation, software reverse engineering and source code reviewing are both recommended to be conducted in a sandbox in order to protect the hosting operating system from being infected with a malware. That is, if in case the software being reversed is infected with a malware. For the purpose of a complete isolation, the following are my recommended sandbox tools with their key features and characteristics. The Vmware Workstation 16 is my chosen sandbox tool for this lesson. Now let's proceed with the installation of the Vmware Workstation 16. But first, let's download it from the Vmware official website. On the official Vmware website, click to open the Workspace tab, and then navigate to click on the Workstation Player tab, which will direct you to the download page of the Workstation Player. On the Workstation Player download page, click on the download button in order to download the Vmware Workstation 16. For the purpose of this class, I'll be downloading the Windows version for the Vmware Workstation 16, since our sandbox platform is a Windows 7 based operating system. Upon the completion of the Vmware Workstation 16 download, I'll proceed to install the Vmware Workstation 16 on my Windows operating system. Note that you can choose to install any of the versions of the Vmware Workstation as your sandbox environment. For the purpose of our lab demonstration, and without any hesitation, I'll go ahead and agree to the Terms and Conditions Agreement without taking much time to read through the Terms and Conditions Agreement statement. But I recommend and I advise you to always read the Terms and Conditions Agreement statement of any software before agreeing to its terms and conditions. For a detailed explanation of the Terms and Conditions Agreement statement of a software and how it works, watch my video on data privacy. The link to the video is on your screen. There's no need to change any settings here on the Setup installation page, so I'll click Next. Here on the User Experience Settings page, I choose to decline the option to join the VMware User Experience Improvement Forum. Then I'll click Next to proceed to the next page. Here on the Shortcut page, I'll leave the default settings, which will create a VMware shortcut link on both my desktop and in my Windows Start folder by clicking Next. Click Next again to complete the installation process of the Vmware Workstation 16. Now click on the Finish button to close the installation dialog box. Now that my Vmware Workstation 16 is fully installed on my PC, I'll now open it in order to initiate the installation process of my Windows 7 operating system. To begin with the installation of my Windows 7 operating system, I'll click on the Create New Virtual Machine tab in order to choose the version of the Windows 7 operating system I intend to install. In my case, I will choose the Windows 7 Ultimate version. You can decide to create a password login access, but for the purpose of this demonstration, I choose not to create any password access requirement. I'll click Next in order to proceed with the installation of my Windows 7 Ultimate operating system. I'll leave the default generated name for my virtual machine. You can choose to either edit or change the auto-generated name for your virtual machine. For the purpose of complete data isolation, I recommend you to always install your virtual operating system on either a separate hard drive partition or on a removable storage device, such as a pen drive or an external drive. So for the purpose of the complete isolation of my virtual machine, I'll proceed to install my virtual Windows operating system on a removable drive. I'll leave the default allocated hard drive storage space for my yet to be installed Windows 7 operating system by clicking the Next button. This is an overview of both the hard drive allocated storage space and the hard drive component that has been automatically designated for my virtual Windows 7 operating system usage. In my case, I would like to increase the number of allocated processor by clicking on the Customize Hardware tab. For the purpose of an effective and smooth software reverse engineering, I recommend you always allocate a lot of processing power for your virtual machine. Click the Finish button when done with the changes made to the hardware component allocation in order to begin the installation process of the Windows 7 operating system. For a better user experience and VMware drivers integration with the virtual operating system, always download the VMware drivers when prompted.
Sweaty beat.
Now that we have our sandbox environment fully set up, let's now install a software disassembling tool. Before proceeding to outline some recommended software disassembling tools, let us take a detailed look at what a software disassembling tool is. A software disassembling tool is a computer program designed to translate a machine language into an assembly language. In other words, a software disassembling tool is a converter which converts a fully designed computer software from a computer language, which is mainly made up of zeros and ones, into human-readable languages such as C++, the C language, Pascal, Ruby Pi, Python, and other programming languages. Now that we know what a disassembling tool is, the following are my recommended disassembling tools. My personal best is the Ghidra, which was developed by the US National Security Authority research team and later got declassified in April 2019 as an open source software disassembling tool. Ghidra is my favorite and my personal best because of its multi-purpose features, that is, its capabilities to function as a debugger, a binary editor, a decompiler, a recompiler of binaries, and as a software disassembling and assembling tool. For these reasons, I'll be using Ghidra to conduct our software reverse engineering. So I'll go ahead with the installation of Ghidra. Before beginning with the installation of Ghidra, let us first take a look at its installation requirements. Ghidra can be installed on the Windows platform, the Linux platform, and the Unix operating system platform, which includes the Mac OS. And because Ghidra was developed with the Java programming language, it requires the installation of at least Java Runtime and Development Kit version 11. On Ghidra's installation requirement page, you can copy to open the official link to download Java Runtime and Development Kit version 11. But I have already downloaded it, so I'll just proceed and install it. The Java Runtime and Development Kit version 11 often work effectively on Windows when it is integrated into Windows environment variable. For this reason, I'll proceed to integrate Java Runtime and Development Kit version 11 into Windows environment variable. With Java 11 Runtime and Development Kit fully installed, we can now download and install Ghidra. You can download Ghidra from Ghidra's official website. I have already downloaded Ghidra, so I'll proceed with its installation. Because Ghidra is a zipped file, it will have to be extracted, but to specifically the Windows programs file in the C drive. This is because Ghidra is not a standalone installation file. So, extracting to host Ghidra in the Windows program files in the C drive will enable Ghidra to function effectively. With Ghidra extracted into the Windows program file in the C drive, open the Ghidra folder and double-click the Ghidra run batch executable file in order to install it. Windows will then open its command prompt to initiate the installation of Ghidra. You may be prompted to integrate your Java Runtime and Development Kit version 11 into Windows environment variable. But since I have already integrated the Java 11 Runtime and Development Kit into my Windows environment variable, Ghidra will proceed with its installation. Note that Ghidra doesn't install any shortcut icon on the desktop. So for this reason, you'll be required to always open Ghidra by double-clicking Ghidra's run batch executable file in the Ghidra program folder you extracted into the Windows Programs folder. With both our Sandbox environment and our Disassembling tool fully set up, we are now set to conduct software reverse engineering.